Hello everyone, welcome back to the channel. In this video, we are going to implement queue data structure, all of its method, which is enqueue, dequeue, adding the elements to the queue, removing the elements from the queue, checking if your stack is full, if it's empty, getting size. All of these methods we are going to implement in this particular video. And the implementation is going to be very simple. You just have to take care of few parameters. So yeah, let's get into the implementation and build a queue using a stack. Before I start, I want to tell you that we can do the same thing using linked list and stack as well. Okay. But just to keep the explanation simple, I'm going to build it using array. So yeah, let's start building our queue using the array. Let's take the mandatory parameters. Private, we are taking one int array, we are calling it items. Now in queue, I told you we are going to use two pointers, right? Which is front and rear. Front is where your elements are adding to the queue, right? And they keep on adding to the rear end. That means the elements that you are adding after the first element, right? They keep on adding one after the other in the back. That we call rear. Okay. So, okay, let me show you both of those. You'll understand with the implementation also how they are being utilized. Let's take those parameters. Private int front, private int rear, private int. We are taking one more variable just to know how many elements are there in your queue. We are taking a count variable. Simple, that's it. I think for now these variables are enough. Let's take a constructor. This constructor we'll use to initialize the size of the initial size of the queue. This dot items is equal to new size. Let's implement our enqueue method. Enqueue is simply synonymous for adding, and dequeue is synonymous for removing the element. So just to keep the classic feel of queue, we are going to name add method as enqueue and remove method as dequeue. Public void enqueue int item. So before we are adding any elements to the queue, right, we want to check if your queue is not already full. How we can do that? We can check if your count is equal to items dot, if your count is equal to items dot length, that means your queue is full. We can throw an illegal state exception, and you can tell whoever is calling this method to that your queue is full. Queue is full. Now if your queue is not full, you're supposed to add. So items dot rear, items of rear, this will become the item. So first the new item that you're trying to add will be assigned to the 0 index, and then we are incrementing rear with +1. So whichever the elements which are coming next will be keep on adding at the rear end, right? Now you increase the count plus plus. Perfect. Now let's implement our dequeue method. I am keeping the return type as int because whenever I'm calling this dequeue method, right, whenever I'm removing an element from the queue, I want to see what element got removed. So yeah, dequeue. So when you are removing elements from the queue, right, suppose your queue is empty, right? So at that point when you're trying to remove an element from the queue, that's an invalid operation, right? You want to throw an error, throw an exception telling that your queue is empty, your dequeue will not work. So for the how can you do that? If your count is equal to 0, that means your queue is empty. In that case, you are supposed to throw a new illegal state exception telling the caller that your queue is empty. Perfect. Now when you're removing the element, I told you that we want to return the element as well, right? So just to keep and hold of that element, removed item is equal to items of front. Now remember, see closely that I have written front, not rear, because in queue it's first in first out. Whichever element you added first is supposed to come out first as well. So we are adding our elements to the rear end, but while removing, we are making sure the elements are removed from the front. Okay, and now you are supposed to change the value whichever was there at the front end, right? You want to change that value to 0. Front, items of front is equal to 0. And why I'm changing it to 0, not -1? Because by default, all of the default values in the array, those are 0 only. So that's why I'm keeping it to 0, not -1. Now once it is 0, you want to increment front pointer. So now front pointer should point to 1 pointer ahead. Now let's decrement the size. Perfect. And return the removed item. Yeah, these conditions, I think I can make this code more readable. Let's refactor this code a bit, then we'll see all these operations in an action as well. Let's extract this condition. On queue we want to extract and tell this is to check if your queue is full or not. So is full. I'm not writing is queue full because these are all called on the queue object only. So queue dot is full, they will be called like that. So is full I think is enough. And what we are doing here, we are checking if your queue is empty. So this we can call is empty. I'm using shortcut of IntelliJ. All they are doing, they are just separating that particular condition into a method. They're keeping that particular condition into a method and naming it whatever you want. Okay, we have extracted those two. I think at the same time, let me write one more method, that is public int size. This will return the size of the queue and it will simply return our count variable, nothing else. That's it. I think this looks good. Let's see if whatever implementation we have done, right, is correct or not. So alpha q is equal to new alpha q. Initially I'm keeping our size of the queue is as 3, right? This is where our constructor comes into picture. We created a constructor, right? So to initialize the size of our queue. Now we want to add the elements to this queue. Queue dot in queue 10. Let me add 2 more elements to it, 20, 30. Now to print this, I think we can override the toString method. Let's do that. We are going to again use that utility class of collection framework, that is arrays dot toString. Simple, nothing extra. Now if we are trying to print this, right, as out of queue, we are supposed to see 10, 20, 30 in our console, and we are seeing that. Perfect. Now let's try removing an element from our queue and then print it again to see what we are getting. Queue dot dequeue and then print our queue again. So we are supposed to remove from the front. So 10 should be removed and we are supposed to get 20, 30. So you see 10 is being removed, 10 is now 0. That's where this condition is coming into picture, and our queue is now has 2 values, that is 20, 30, right? Now I think we are getting all these fine and all. Let's try our count method also. Currently we have two elements, right? So count value should be 2. S out q dot size, this should return 2 count, it is returning 2. Perfect. So now you see we are able to implement the whole queue using array in a very simple way. This is not any rocket science code or anything. You can see all the elements that I have implemented. And yeah, now there is one problem in this code. Okay, that problem is if you are adding an element, right? Let's say now you are adding one more element. It is 40, right? It is supposed to be added in this place, right? But when you're trying to add it, right, you will get an exception. It will not get added to the queue. You will get an exception, array index out of bound exception. So our assumption was that it will be added here, but that did not happen. So this problem we are going to solve in next video using the help of circular array, right? Meanwhile, if I run till this point, you'll get everything awesome, no exception, nothing. So you can practice this implementation first for a simple understanding of the queue. In the next video, we will be understanding what is a circular array, and we'll be solving this problem also that we have seen just now. And then we'll be going ahead with some different implementation. We can also implement queue using stacks also. We'll be seeing that. So for now, that's all as part of this video. Practice this, understand how queue operations work, and see you in the next one. May the source be with you.